Hello, friends. It's good to see you on a very rainy day. Thank you for making the trek over here. Those of you who had to go far, you get extra credit. In my heart. No. None of you needs to worry about extra credit. I haven't mentioned it yet, but there will be one more opportunity to get one more point of extra credit for filling out a Qualtrics survey per my usual, so I will let you know when that is available. Grades I just updated like 30 seconds ago, so you should have all of your quizzes, including the one that you just finished, all of your homeworks through homework 7, which is the only one left, so we're almost there. It's getting real, right? This is 3 classes left. We will do evaluations, the official kind that the school cares about, a week from today. I do not find them particularly helpful, but I have to do them, and I have to allow time in here to do them. So there's your official notice, although it's been on the syllabus since the beginning of the semester. We now can talk about homework 6, if you would like to do that. Everyone has finished it. This was the study of thumb sucking. So inspired by a true story, my niece sucked her thumb, and she didn't care anything about what it was going to do to her teeth, and now she gets to wear a palate expander. The thing that she did care about was that she could not wear nail polish until she stopped sucking her thumb, and so that did the trick. So the story behind this story here is that kids don't care about their teeth. They care about being big boys and big girls and all the things that affords them to do. So the teeth-based program was not as effective at reducing thumb sucking. So all of you had that same story. We can go over the non-box questions here real quick. So most of this is the same as usual in terms of doing a 2-level model of change over time. The only catch is the idea that you're predicting this percent correct outcome using a binomial model. So I think most of you had no issues really getting the numbers correct, so we'll just do interpretations here. So intra-class correlation is always the between. Between what depends on the design. So in this case, if we're talking about the percent of variance that's due to the intercept, the random intercept at level 2, that's between persons. And that's always degrees of freedom 1 if you're adding a random intercept variance. And let's see, we have, section 2 then. It was a random linear time model, so in this case I allowed you to go straight from random intercept to random linear time because you could use Cove test to do the likelihood ratio test for the slope in and of itself. Adding a random slope, that's degrees of freedom 2. We made the model significantly better, and the fact that something random was significant indicates significant individual variability rather than significant average whatever. Significant average whatever is if a fixed effect is significant. Significant individual variability is if a random effect across persons is significant. And then last but not least, we looked at the effective program. So I asked you to do a multivariate wald test to look at the combined effective program on the intercept and the slope. So that is a contrast statement in which you list both of those terms separated by a comma so that SAS understands its degrees of freedom. So it should be degrees of freedom 2 for the numerator. Denominator I gave you because that's based on sample size. And we found that the rate of change was significantly negative in both groups, but it was more negative in the maturity focus group than the teeth group, such that there were no group differences at the beginning. They emerged halfway through, and they remained significant at the end. And so you had 2 specific effect sizes. The main effective program, main effects always reduce the intercept of some kind. Which intercept it is depends on the level of the predictor whose main effect you're talking about. In this 2-level design, it's a main effective program at level 2, reduces the level 2 random intercept variance. And that means the interaction of program by time. So this is the right answer because it's level 2 random variance because we're talking about the effective program as a moderator of the level 1 linear effect of time. So program by time gets you that cross-level idea of a level 2 variance in the level 1 slope. You get to do that lots and lots of time on homework 7, which is now available as of this morning. I checked and checked and checked, and I really hope it's right all the way through. So the story here is the same type of intensive longitudinal design. So I tried for authenticity to some extent. So Lindsay, tell me if this is okay. Participants were asked to drool onto an oversized cotton swab 4 times a day. I tried.
You kind of combine the 2 methods, but this is a fun new method.
Okay, well this is what they're doing in my world here. I actually had some 3-level cortisol data from a study I helped with as a postdoc, and so I started out with real data numbers, but I had to jiggle them so much to make the story come out the right way for all of you that I just admitted by the end of this that it's cortisol on some metric that you would never recognize. So just ignore the numbers, right? Your mean is going to be 20. What that means, I don't know. So it's in units of, what did I say, unicorns per rainbow. That's what the measure of cortisol is here. You have 4 occasions within a day, 7 days, and 100 graduate students who participated in exchange for toilet paper money. So this is a relative, I told you I'm keeping it realistic, right? I took out student loans in graduate school even though I was a GTA so that I could pay my bills each month and, live, as my dad would say, high on the hog in my 1-bedroom apartment, right? The sad part about all of that is that I waited tables as an undergrad, and when I became a GTA here at Kansas, my salary was cut in half relative to what I was used to for the same amount of work. So yes, cheers, toilet paper money in exchange for drooling onto Q-tips. So it's a relatively simplified story as compared to the example we're doing. You're looking at changes in cortisol over the day, and I know that cortisol follows a pattern of decline throughout the day, and the extent to which some people have a flatter decline or a flatter or steeper decline is some sort of indicator of health. So we're looking at the time you woke up as well as your stressful events each day at level 2, and then their means at level 3. So you'll be doing all the instructions here in terms of how to set the variables up are there. Let me know if you have questions as you get started. This will be a 12-point homework, bringing us to our total for the semester. And it is due the Friday of finals week. I haven't decided if I need to do office hours during finals week. Does anyone have an opinion about that as of right now? No opinions? Okay, I'll ask again next week because I need to make sure that this room is available or else figure out where else I can go. So the other thing we have to go over then while folks are still chewing is quiz 6. So there's the researcher from, it should be quiz 5, but I couldn't figure out how to change it, is back. She continued her previous research project in which she was looking at an effect of an intervention assigned to teachers on a student-level outcome, but now it's a longitudinal study. So we have student outcomes measured across 5 occasions, and she still wants to ensure that teacher-administered intervention, so this would be level 3, is equally effective for students of different abilities, and students are level 2. So here are the questions then. Number 1, based on the design, what are the level 2 and level 3 ICCs for the level 1 predictor of time going to be? So the key here is that all the students were measured at the same time. Therefore, what's my level 2 ICC for time going to be? Level 2 is the proportion of variance that is between persons and higher, cross-sectional. If everybody's measured at the same set of times, 0, yeah. So there's no variance between persons in time because time is the same for everybody. It's the same 5 times. That's the level 2 ICC, the proportion of level 1 variance that is at level 2 or higher. That would be 0 for time. And if ICC level 2 is 0, that means ICC level 3 has to be 0. ICC level 3 is the proportion of variance 2 or higher that is actually a 3. Questions on that one? Okay, Likewise, treatment versus control. That is a teacher level variable at level 3. So its inter-class correlation at level 3 is going to be what? How much of this teacher level variable is across teachers? All of it. So that means ICC level 3 has to be, what does all of it mean in math? 1. And that means if ICC level 3 is 1, what is ICC level 2? It's also 1. So of the variance that, let's see, of the total variance, all of it is at least between persons. Of that, all of it is between teachers. So they're both 1. So the only one you had to do any math for was this one here, for student ability. So I gave you the proportions at each level. So 10% is because students have different abilities at each occasion. 60% is level 2 is because students have different abilities on average. And 30% is because there is a commonality in the ability of students from the same teacher. So if we put those proportions in the formulas, the first level 2 ICC is the split of level 1 versus the others. So 90% of the total variance is at level 2 or higher. So 90% of the variance is cross-sectional, 10% is longitudinal. Of that 90%, a third of it is at level 3. So that makes the level 3 ICC 0.33. And yes, I gave you easy numbers to try and be nice. No calculators needed. Okay, how did that one go? You'll get more practice with homework 7. You get to do these kinds of interclass correlations again. And then at what levels can each of the following predictors have random slopes? We'll do the easy one first. Level 3, control versus treatment. No random slopes because it's level 3. What would I need to have in my design for level 3 random slopes? Or a level 4, yeah. So a level 3 predictor cannot have random slopes because there's no higher level for those slopes to be over. You need to have a level 4. By that same logic, can we have level slopes? Random slopes for level 2, student gender, for instance? Yes, we can, over 3. The effect of gender can vary across teachers. And level 1, student ability at each occasion. Level 2 and 3, and that's the end of the question, but I should have actually asked you more than that. Level 1 student ability at each occasion, we're thinking of that as a time varying level 1 predictor, right? Can I just stick that in my model as a predictor and be done? Am I allowed? Nope. And we know that because I already told you in this question that student ability has variance across levels. I'm thinking of it as time-varying student ability, but only 10% has to do with time. Most of it has to do with student, and even some has to do with teacher. So this is what we talked about last time. We have choices in how we carve up that variable to represent the variance that it has at each level as a predictor in each level of the model. So if I wanted to do, so this is transitioning from quiz to review now, by the way. If I wanted to do variable-based centering, we'll call it that. That's the idea of taking each level of information specifically and turning it into a predictor. So let's say that I have ability, T, time within student, within class. Let's go like that. That's my original variable. I would create something that's like level 1 ability equals our ability, and what goes here? How do I take time varying ability and turn it into a purely level 1 variable? Subtract what? Person mean, we'll call it student mean here to keep it consistent. Student mean ability, and I'm going to give that subscripts of SC. Then level 2 ability equals student mean ability minus what? This is the one we'd normally put a constant here, but it's 3-level model. Yeah, teacher mean or class mean, we'll call it. We already have T for time, so I'll go with class. Ability, and that gets a C because it varies over classes. And last but not least, level 3 ability. Class mean ability minus what? I heard it. Say it louder. Constant. Yeah, we'll just make it a C. Sorry, that's an inside joke for my husband. There's a sign when you enter Iowa at the Welcome Center, and it just has question marks on it. And I was like, is this Iowa? I don't know. It's just funny. So yeah, means Iowa. So we center at Iowa. So we've taken what was one predictor, measured at level 1, and carved it up into its level 1, 2, and 3 parts. Each part has a unique effect at its own level. They're orthogonal. Level 1 predicts level 1 variance. Level 2 as a main effect would predict level 2 random intercept variance. Level 3 as a main effect would predict level 3 random intercept variance. Now, which of these things can be random over what? Same rule applies. How about level 3 ability? Can that have a random effect in this 3-level model? No. Can level 2 ability have a random effect in this model? Yes. So that would mean the extent that ability matters in predicting student outcomes varies across classrooms. So one's average ability over time, to the extent that that matters in predicting one's own outcome, that may vary across classes. That's what a random effect of the level 2 variable would be. How about level 1 ability? What can that vary over? The effect of level 1 of variability can vary randomly over level 2 and level 3. So a level 1 ability is the idea that being more able than usual means you do better at this occasion than usual. The extent to which that is the case may vary by students, and that student level tendency may have some class level variation in it as well. So yeah, it gets tricky quickly. But the rules are always the same. Step 1 is figure out what kind of variance you have in each predictor at what level, and then you can figure out where it needs to go in the model. So any questions on that? All right. Do you want to look back at the example we started from last time then? since that's going to be similar to your homework. So we got through the time part, but we will review the first part, if that's all right. Carving up variance in a slightly different way. So I make a point of presenting this because I've gotten into, I wouldn't say arguments, but debates with other people about whether these kinds of designs should be 2-level or 3-level. And I always say it's an empirical question. Whether or not there's systematic variance that goes on the day level depends on what kind of outcome you have. And we can find that out by contrasting different types of 3-level and 2-level models. So our story here is that we're looking at self-reported ratings of fatigue four times a day on days 3 through 20 of an EMA study, ecological momentary assessment in 25 adolescents. So there's a total of this many observations here. So we started out with a 2-level model, but to try and be consistent with our labeling, it's actually just level 1 and level 3. So what we were calling level 2 day has been lumped into level 1 time. So all of the observations from the same person are being treated as level 1, and people are being treated as level 2 according to SAS. So that intraclass correlation of the total variance in fatigue, about half of it has to do with which person we're talking about. Is person mean differences. Some people are more tired than others whenever you ask them. So intercept mean fluctuation. And that intraclass correlation of 0.52 is different than 0. We test that by comparing an E-only model to one that has this extra random intercept across persons. That's what this likelihood ratio test is doing for you. We then contrasted the fit of that version of a 2-level model with a full version of the 3-level model, adding back in level 2. So level 2 goes in the middle here to distinguish observations from the same day. So in asking whether 2-level fits worse than 3-level, what we're asking is whether or not observations from the same day are more correlated than observations from different days, both within the same person, though. So holding person constant, what is the correlation of occasions from the same day? And in this case, the model does get better. We can look at the proportions of each, and I did put up the new version of this handout, I hope. Hope I remember to do that. If not, I'll do it after class with these labels fixed. So of the total variation, here's my 3 variance components, 51% is between persons at level 3, 13% is level 2 across days, and 36% is within days. From there, we can compute a couple different kinds of intraclass correlations. A level 3 intraclass correlation for level 3B. So this is not the one that we just did in your quiz, and this is not the one I'm asking for in your homework, by the way. This is a new one, because I don't talk about it very much. I didn't think it was fair to ask you for it. But this is just the straight proportion. How much is level 3? Of the total, how much is level 3? ICC level 2B is the one that tells us whether or not we need day in the middle. So, do you want to go over these some more, or do you feel like you have them? Maybe one more? All right, let's break this out here. Let's do this. Because this is confusing. I'm not going to lie. This is where we really start earning our advanced multi-level modeling cred, right? All right. So these are my 3 proportions. 51% is level 3, 13% is level 2, 36% is level 1. So we can do an ICC level 2, that's the normal kind. And I'm going to do these as the percents to make it a little easier to keep track of. Like that. Total, which is 1. So let's do that. Oh, and I have to do math in front of you. 64, right? No, I'm actually not kidding. I'm asking to make sure that I did math correctly in front of you. So yes. So this ICC level 2, what that tells us, I'll put this expected correlation of occasions from same day and same person. There. Why is this so big? Look at my print layout. It's a little bit better. No, I don't like that one. Sorry, I'm trying to make this fit. Okay. So in this kind of design, that's not terribly useful, I think. This one, that one's okay. ICC level 3 would be 0.51 over 0.51 plus 0.13. Anyone help me with that? .796? Sure. So that one, expected correlation of days from same person. That one needs a little bit more. If we think of these as proportions of variance, I can also talk about ICC level 2 as how much is, I can't cross-section on that one, between days and higher. And for ICC level 3, I can say this is of day variation, how much is persons? So those are the versions that I'm asking for in your homework. ICC level 2, ICC level 3. For this type of design, they don't necessarily make as much sense. So I will give you the comparison then. ICC level 2B, which I just invented for this handout. It's not in the book. That is going to be 0.13 over 0.13 plus 0.36. And that one should be in the handout. .27. Hopefully that's right. This tells us expected correlations from same day, controlling for person. So it's like ignoring person. And you can also say how much is just here we go, of longitudinal variation. How much is between days? There. So the first ICC level 2 is less helpful in this case, I think, because it's lumping together days and people. The second version, given the design, I think is more helpful because it's ignoring persons and it's just talking about days versus occasions within days. ICC level 3 is the expected correlation of days from the same person. The one that I gave you, which isn't in the book because it's also found elsewhere, ICC level 3B, would be just the 0.51 over total. And that one is a little bit weird in terms of expected correlation. It's the expected correlation of occasions from same person, not necessarily the same day. Proportion of variance that is cross-sectional in this case. Proportion total variance that is cross-sectional. So I can't tell you which is right and which is wrong. All I can tell you is that some of these numbers may be more or less helpful to describe your case than others. But here's where you can never go wrong. Do this for them. This much is 1, this much is 2, this much is 3. From there, any interested reader can carve these up into proportions however they'd like. This is the way that I do it for cross designs also. This much is due to this source, this much is due to that source, this much is due to that source. Just be very clear in your wording. If this is what you're doing, call these proportions of variance. Of the total variance, X% is this level, X% is this level. Don't call them intraclass correlations. If you're going to use an intraclass correlation, in 2-level data there's only one, and people will be able to follow it, but in 3- and 4-level data, you have all of these choices. And there's probably even more that I haven't thought of. So that's where you have to be very tricky. It gets tricky to be careful, but you do have to be very careful to explain what you mean. Better? As better as it's going to be anyway without lots of practice? Yeah. This. Do this. There's your take home. All right. So we did the same process for all the variables, figured out that negative affect is measured at each occasion, also has variance at levels 2 and 3, most of which is actually 3. And time of day has a little bit of variance at level 3 as well, even though it's a level 1 predictor. And last night's sleep also has variance at 2 and 3. Then we looked at pictures. So to create these pictures, because time is unbalanced, I don't have a variable that would work for things like occasion, right? The data set had one. There's absolutely nothing in terms of what time of day it was. So I have time of day given by the clock. The equipment that recorded their responses knew what time it was, and I rounded that into the nearest half hour just so that I could make a picture. So rounded time of day goes on the model line and on the class line. That makes it create a separate mean for each unique time value. And I did it in Glimix so that I could add this part right here that would not only spit out the means but make a picture of them. It's not in my version of mixed. And so this looks sort of quadratic-y to me. I took those means and pasted them into Excel so that I could add a trend line, and indeed this is what we're going to model, something that looks quadratic. I put the centering point for time right here at 15 o'clock, otherwise known as 3 p.m., because that's towards the middle. We then looked at level 2, which is day of the week and day of study. Not much happening with the day of study, but day of the week, the sample has a case of the Mondays. So we're going to control for that before we look at the effect of negative affect, for instance, because negative affect may be correlated with whether or not it's Monday, just like fatigue. So then we get into our first unconditional model that includes time. So fatigue is my level 1 outcome. Each day gets its own intercept, its own linear slope for which hour it is in the day, and its own quadratic slope for which hour it is in the day. So these beta placeholders are giving day a prediction. I come up to level 2 day, and those beta placeholders get defined with person placeholders, one to begin each of these equations. I also have a level 2 fixed effect for whether or not it's Monday. That's a dummy code, and a level 2 random intercept. I've got nothing here except placeholders for linear and quadratic time of day. Then I come up here to level 3, and each of these 4 level 3 placeholders gets its own equation. So delta OOI is how each person gets their own intercept, its fixed intercept, plus their person mean hour of the day. So this is a contextual effect, given that I have hour minus 15 at both level 1 and level 3. The idea is that when I talk about time of day, I really want to talk about time of day and not person differences in their schedules. Because to the extent that some people wake up earlier and go to bed later and vice versa, time of day is a person thing. And when we did empty models just a second ago, there was 3% of the variance that was time of day was person. So I'm throwing in person mean time of day, not so much because I care about that, but because I really want to make sure that time of day is time of day at level 1. So I'm unsmushing time of day at level 1 by putting in person mean time of day at level 3. And I have to do that for the intercept as well as for the linear slope of time of day and the quadratic slope of time of day. And then I have a person intercept here and a fixed effect of whether or not it's Monday. So if we tie the equation to the syntax here, gammas are fixed effects. Those are the things that show up on your model line. So we always have an intercept unless you shut it off. The fixed effect of Monday shows up right here. The fixed effect of level 1 time shows up right here. That's what L1T means. The fixed effect of level 1 times squared, that's right here, gamma 2O. Level 3 time as a main effect, that's right here, gamma 001. Level 1 by level 3 time, that's this interaction term, gamma 101. And level 1 times squared by level 3 time, that's gamma 201. So if we look at the subscripts on these things, they're very orderly, even though it looks a little complicated. The first one has to do with what you're talking about at level 1. The second one has to do with what you're talking about at level 2. And the third one has to do with what you're talking about at level 3. So if I go to this first line, for instance, right here, this level 3 person intercept, it's 000 because this is the fixed effect for the intercept. So everything in the level 3 here starts with O as its last place because that's like the intercept of each equation. It's the jumping off point for the equation. These are all referring to how do I say this? They're all referring to their placeholders at beta 0 that are the jumping off points as well. So the second is 0 in here. And these are the order of the predictors at level 1 in the first place. So this is gamma O because we're talking about beta 0. And this is gamma 1 because we're talking about beta 1. And this is gamma 2 because we're talking about beta 2. If we go to level 2 here, this is a delta O1I because this is the first predictor of beta 0 at level 2. And so that O1 delta right here comes down to be the Monday effect at level 3. And so this is where we will put any person-level interactions. So we can test individual differences in the extent to which it being Monday matters. And so if we had fixed effects then on this very last line, it would be like O11, O12, O13. Fun, right? Isn't it? It's like one of those stupid magic eye posters. Once you see the sailboat, you can't unsee it. I promise you. Just look at how good you are at estimate statements now. They're the same way. Ironically, I still have never seen the damn sailboat. I cannot see through those pictures. Yet another one of my deficiencies. All right. Okay, so here is my model solution, I should say. And no, I am taking pity on you, and Proc Lesa is labeling shit left and right. You're welcome. This stuff is hard. So here's my level 3 random intercept. And I have a note here to pay attention to the degrees of freedom. So they are mimicking the level at which these predictors are measured right now. So because we have a random intercept at level 3, your intercept degrees of freedom look kind of like level 3 sample size, which is 25 people. Monday looks kind of like the number of days in the study because right now it's being treated as a day level effect. And both level 1 time and level 1 time squared have degrees of freedom that look closer to the number of occasions, total occasions, minus days minus persons, which is level 1 sample size. Level 3 time is a person thing, so its degrees of freedom look more like the number of people, and the cross-level interactions between level 1 and level 3 look like level 1 occasions. So as we add stuff to the model that makes these terms random, these degrees of freedom are going to change, and they're going to look more like the level at which these effects are random. So if we talk pseudo R square then, let's take guesses here. Is whether or not it's Monday a person thing, a day thing, or a time thing? Day thing. So which of my terms for variance should it explain? A person thing, a day thing, or a time thing? Day thing. Yay. How about level 1 time? Is level 1 time a time thing, a day thing, or a person thing? Time thing. So should it explain person variance, day variance, or time variance? Time, yes. How about level 3 time? Is level 3 time a person thing, a day thing, or a time thing? Person thing. So should my person thing explain person variance, day variance, or time variance? Person. Oh, and now here's the tricky ones. Cross-level interactions between a person thing and a time thing. What's the rule for cross-level interactions? It depends. It depends on whether the lower level term in the cross-level interaction has a random slope or not. Do you see any random slopes here yet? Nope. So if there ain't no random slopes, where does it have to go? Residual. There you go. Now these are unbalanced data, and they do not behave in this type of expected way, but that's what should happen. And so here are my pseudo R squares. And yes, I even labeled these for you, because that's how nice I am. So we have about 4.6% of the person differences explained by person differences in time of day. 3.6% of the level 2 day variance explained by whether or not it's Monday. People are tireder on Mondays. And yeah, significantly tireder. Is tireder a word? Word, people? No, it's not? But that's just like unnecessarily complicated. It's tireder. And level 1, what time of the day it is explained 3.1% of the variance. And so here's my little box for total R square. So 8% of all the variance in fatigue is explained by something to do with time. So I'm lumping all of these fixed effects together because they all have something to do with time. Time of day, person differences and when they took the surveys, and whether or not it's Monday. Okay. How are we doing? You hanging in there? We're doing it. Wake up. I'm here. I'm not happy about it, but I'm here. So now, which things can be random? I am testing whether or not we need random time of day effects for the day and then for the person, but I'm actually going to do it backwards. I am breaking my own rules. So you have heard me talk about linears and quadratics and how you have to have the linear for the quadratic to be interpreted correctly. In these data, I ran into problems trying to estimate both linear and quadratic effects of time of day randomly across 2 and 3. So I decided to pick which of them seemed more important and start with that one first. And given this trend that I'm trying to approximate, random quadratic seems more important than random linear. So some may disagree with this, but I'm testing random quadratic first, and then I'm seeing if random linear is also needed. Because that's what it looks like, and I don't have a lot of information. I've only got up to 25 people at level 3 in particular. So I'm shortcutting the code here. So here's model 2B that adds my random quadratic time of day variance across days, and then model 2C that adds my random linear time of day variance across days. So adding the quadratic first, fit test says yep. So the extent to which you see that quadratic trend of fatigue varies randomly across days. Not all days have the same amount of quadratic trend. I then added the linear part, although in convention with my normal labeling system, I wrote it first, and that was significant too. And when I looked at their correlation in G-core, it was far off the boundary of -1 and 1, would suggest that they are two separate things, and then it's fine to have both of them. So I have that. So I've divided up my coparms table here and underlining the sections here. So here's my level 2 model. So I'm allowing day differences in the quadratic and linear and quadratic time of day effects. After doing that, note what happens to the terms involving level 1 time of day. Their degrees of freedom look more like level 2, and their standard errors are going to be higher. So I point this out because you can have fixed effects related to time that were initially significant before you add random effects for them, and they can become non-significant after you add random effects. And that's going to be a function of the standard error that they're estimated with, as well as the degrees of freedom. But even if they become non-significant, we leave them in, because the random effects are varying around the fixed effects. I then repeated the same process by adding random quadratic and random linear effects to level 3. So now I'm saying, of the differences across day and that time of day effect, how much of that is really differences across people? Some people have more pronounced quadratic fatigue effects than others. And indeed, they do. So I don't have very much power to find this, so I was pretty surprised to find it. I have 25 people, which is really not a lot for random effects. So there is significant random quadratic time of day variance. I went and did the linear, and it's not significant, and so I'm sticking with quadratic only. And the degrees of freedom with which each of these terms is estimated, with a significance tested, I should say, matches this level 2 versus level 3. So you know how to do all of this. So the conclusion is the extent to which this shape holds, this amount of quadratic change across day holds varies across days, and that varies across persons too. Not everybody has the same amount of time of day effect when it comes to their self-reported fatigue. Here's my total R square, and let's see. Yeah, that's not all I want to say about that. Here we are. There we are. Back here now. Now I'm adding a random effect of Monday. Monday is a level 2 predictor, so it can be random over persons. What would that mean, folks? What would a random Monday effect mean? Individual differences in how much more tired people are when it's Monday. See, I said more tired. Individual differences in how much more tireder people are on Monday. As it turns out, nope. Everybody's more tired on Monday. So that pretty much is everything I can think of in terms of what I would do with respect to time for this type of data, with one exception. Do you remember the alternative covariance structure models? Types of genes, as it were? Well, almost all of those require balanced data or equal interval data to be used, like a Topolitz and an AR1. The only one that doesn't, I wanted to give you an example of how you would do that. AR1 R matrices can be estimated for unbalanced time in SAS with this option right here, SP-POW. Sounds kind of like a cartoon character, but this stands for spatial power structure, and you list continuous time after it, and it estimates an autoregressive pattern paying attention to exactly how much time there is between occasions. So in theory, this could be very, very useful for modeling additional correlation because you have occasions that are closer together in time. In these data, though, I tried it and it didn't converge, and so that suggests that I don't need it. So if we look at the model that we have right now, the variance components that we have right now, let's find those right here. I've already got a lot of non-constant correlation in there. If I only had random intercepts, like in the empty model we started with, random intercepts imply constant covariation. So that would mean that all the days have the same correlation that come from the same person no matter how far apart they are, and likely also that all the occasions within the day have the same correlation no matter how far apart they are. In adding these quadratic effects of time of day at level 3 and these linear and quadratic effects of time of day at level 2, we're changing the expected pattern of correlation and the expected pattern of variance. So days will differ from each other more at certain times of day. And occasions that are closer together in time will have a different pattern of correlation than occasions further apart. So that's what these random slopes for time of day are doing, making sure that we have a variance structure that's plausible. In this type of data, would I ever know if I have the right answer? Can I just be like, type equals unstructured, what is it? What do you think? I've got like 60-some observations per person and 25 people. Think that's going to work? No? Do you think a 60 by 60 matrix is going to be estimated well on 25 people? No. But even if I had 1 million people, what do you have to use unstructured? Balance. Did everybody complete their survey at exactly the same time every single day? Nope. So I'm never going to have an answer key. And this is way more common in longitudinal data than equally spaced, complete, balanced observations. You just kind of have to reason your way through it and do things that make sense. And phrase additions to the model as testable hypotheses. So I'm saying I'm done because I've done everything I can think of. There may still be things that I haven't thought of yet. But I've done my due diligence in trying to control for time before we look at the other stuff that is potentially more interesting, like negative affect. So who here gets more grumpy the more tired you get? If you're feeling grumpy, do you feel like you're more tired too? Yeah, I'm not claiming causality. I don't know which way it goes. I'm making fatigue the outcome and negative affect the predictor, but really this is more well suited for a multivariate model. But we're going to get there eventually. We haven't got there yet. So I'm taking negative affect, and I carved it up using variable-based centering, as we've been talking about, into its own variance at each level. So I put the new parts of the model here in blue. So at level 1, beta 3 is how each day gets its own effect of being grumpier than the rest of the day. That beta 3 then becomes the within day negative affect effect right here, which has a placeholder for what it becomes at level 3, which is just the fixed effect. So gamma 300 is the fixed effect for how much more tired you feel at this hour than you felt the rest of the day because you were grumpier right now than you were the rest of the day. So these are within day fluctuations of negative affect and fatigue after controlling for time of day and Monday and all that stuff. Level 2 then. What is the effect of being grumpier than usual today? So level 2 shows up right here. This is my gamma O2 being multiplied by the day's negative affect mean minus the person's negative affect mean. So if you are as grumpy as you tend to be today, that goes to 0. If you're grumpier than you usually are today, that's positive. So this differentiates good days and bad days at level 2 as opposed to good hours and bad hours at level 1. So that gamma O2, or excuse me, that delta O2I then has a placeholder at level 3, gets its equation gamma O2O for the fixed effect. Last but not least, person-level negative affect. Are you just a grumpy-ass person? Because that may be bad for you too and make you feel more tired. Gamma O02 multiplies person mean negative affect minus 10, which was near the mean of the scale, which is the effect of being a grumpier-ass person than someone else. So there's 3 kinds of negative affect here. The effect of being grumpier right now than the rest of this day, the effect of having a worse day than you usually have, and the effect of being a grumpier person than other people tend to be. 3 different things. Okay, how are we doing? Do you want to know what happened? So all of that, what looks like a whole lot of overkill, maybe it's just job security, but it does start to help once you have interaction terms. But all of that is right here. L1 NA, L2 NA, L3 NA. So you can see the beginning of the code for how I created those variables, but I did them through variable-based centering as just described in the equation. Everything else is the same. And here are my fixed effects. Each is significantly positive. So yes, being grumpier, either than the rest of the day at level 1, today relative to your other days at level 2, or than other people at level 3, is related to being more tireder. So each unit, if we look at the coefficients, you might be inclined to think, well, if I look at these numbers, 0.6 is bigger than the others, so maybe this one's more important or a bigger effect size. Can I say that? You're like, can you? Because I really want to. These are unstandardized. So I can't say that 0.6 is bigger than 0.2 without knowing the standard deviations of these predictors and knowing the standard deviations of the piles of variance that they're trying to predict. I have something in the book I made up called pseudo standardized effects that you could do for something like that. But just to remind you that these coefficients are based on these scales, and so you can't just look at them. But I can say that at level 1, for every unit more grumpy I am right now than my day's average, I am more tired right now by 0.2. At level 2, for every unit grumpier I am on average today than my other days, I am more tired today on average by 0.4. And at level 3, for every unit person mean grumpy I am more than other people, I am person mean tired more than other people by 0.6. So grumpy people are tired people. Did you know that? Or tired people are grumpy people. And so if we look at these as just main effects, in terms of what should have happened as pseudo R square, each of them should have reduced the level 1 intercept at level 1, the level 2 intercept at level 2, and the level 3 intercept at level 3, right? That didn't happen. For reasons that I still do not know, the quadratic time of day variance went down by a considerable amount. That should not have happened without an interaction of time of day, and I tested it and it wasn't significant. So I'm going to attempt to go Iowa on this one. If you figure it out, let me know, because I don't know. But what I do know is that 85% of why some people are more tired than others on average is because some people are more grumpy than others on average. And 23% of why some days people are more tired than on other days is because they are grumpier that day than other days. But only 7% of the reason why you're more tired right now is because you are more grumpy right now than the rest of the day. We have the potential for 3 different random effects. I tested all of them. Within day, negative affect at level 1 could vary over 2 or 3. And between day, negative affect at 2 could vary over 3. So those are models 3B, 3C, and 3D respectively. The first one is significant. So the level 1 negative affect effect varies randomly over level 2 units. So the extent to which if you feel grumpier than usual today, you are feeling more tired than usual right now, that varies over days. It does not vary over people. And there was no significant effect of level 2 negative affect over people either. Now we get to the story. I want to know if you sleep more, if that reduces this relationship. And the story actually ended up being more complicated than I thought. So I'm adding sleep as two new variables, level 2, which is how much you slept last night as a day level predictor, and then the person mean of that, how much do you tend to sleep as a level 3 predictor. So here is my level 2 predictor up here in blue, and then my person mean predictor here. I also looked at a random effective person mean predictor, but that wasn't significant, or didn't converge actually, so we don't have that model output. So we're adding these two fixed effects right here. And they're not significant. This one's so people who sleep more are not more tired or less tired. And on days when you slept less than usual, you are a little bit more tired than usual. That's the level 2 effect. Again, some of the terms moved around in ways I would not have anticipated. But here's the grand finale. Look at this effing equation. If I had shown this to you like on the first day of last fall, what would you have thought? Or the first day of this spring, for those of you who weren't here? It's still like, whoa. But it's not as bad, right? This is the advanced MLM class. I keep it real up in here. So here's my level 1 interaction of negative affect by level 2 sleep. I also have the within day negative affect multiplied by sleep, so that's 2 by 2. At level 3, here's 3 by 3 for the 2, so I've added 6 new interaction terms. This one is within day negative affect times person mean sleep, between day negative affect times person mean sleep, and level 2 sleep times person mean negative affect, and then there's the other 2. Holy crap. But some of them were actually significant. So not at level 2. Nothing happening at level 2. But we do have patterns at level 3. And they're negative. So as described here, and as shown in the words, see, look at all these lovely words, everything I just said. It looks like sleep is a moderator. The extent to which feeling grumpier than usual is related to being more tired than usual is less in people who sleep more. So go home and take a nap. That's your thing here. So I have like 1 minute left. I want to ask you guys a question about next week. We're getting to multivariate, but I don't have a lot of time, so I got to be choosy. I know some of you I've talked to about multivariate models in your research, and so I want to make sure I try to hit what I can that's going to be most useful. So who here wants to hear about like mediation-y kinds of things in M+? Take a couple people, one or two people. I know, Katie, you want to do your multivariate thing. I've got one for you. Has anyone else heard me say, oh, you need a multivariate model for that when I've talked to you before and now you want to come do? What do you want to do? Like a path model-y thing, mediation, growth mediation something? Maybe. Andrew, how about you? Have I talked to you about your stuff?
No, but I do like a good path.
Like a good path model? So path models you can do for fluctuation data or growth data. I have one for growth already, and I have one for fluctuation already, so I can hit those. Any other multivariate things that I've talked to you about that you want to hear about?
Path is similar to the unconditional model that we chatted about, some ways that they broke.
Path models is just the idea of one outcome predicting another. So like if you have a time-varying predictor that grows, you can fit a growth model for it and a growth model for your outcome, and then you have relationships between your intercepts and slopes. That sounds good? Okay. All right, well, if you think of anything else, let me know. I'll put the stuff together, and I'll see you next week. So office hours start now. Have fun with homework 7.